Here's a practice problem on piecewise defined functions. So the piecewise defined function is this piece when x is less than 3, and this piece when x is bigger than equal to 3. Both pieces are linear functions, and the first part is asking you to find different values of this linear function for this piecewise defined function. So g of -1, I can see that the input x, so x is -1 and is less than 3 is fitting this piece. So I'm plugging it into that piece. That's -7. Then for the next one, I can see g of 2. Again, 2 is less than 3, so it fits in there. So every time you put in the x in all the pieces, see if it fits. And so I multiply, and I get 5. The next one says g of 8. G of 8, and 8 is definitely bigger than 3, and so fits right there. So I plug 8 in there. -8 plus 5, and I get -3. So the answers are, for part A, these are the answers. Now it's asking me list all intervals where g is increasing. Looking at these two lines, I can see the slope of this line is positive. That means that rate of change is positive. That means that the function is increasing. So for x less than 3, the function is increasing. I have to put it into interval notation. So anything less than 3, you can do a number line and put a 3 in here, and everything less than 3 starts at -infinity and ends at 3. For part C, it's asking at what interval g is decreasing. I can tell that the second one has a negative slope. Negative slope means decreasing. Negative slope means the rate of change is negative, and so on and so forth. Same discussion as that. And so you never include the endpoints for increasing and decreasing. You just say x bigger than 3. So here, 3 to infinity, basically, on the number line. Let me do this. That piece was for the previous one. This piece is for this one. And the answer that I'm getting is going to be 3 and infinity. The last part is asking me to find the range of g, basically. Here I know that I basically need to know what happens at x equal to 3 before and after, very immediately before and after 3. So for part D, I kind of need to know the shape of the graph. In here, if I plug in 3, if I plug in x equal to 3, x equal to 3 is going to fit in here. So if I plug in g of 3, I will get -3 plus 5 equal to 2. And so at 3 and 2, 1, 2, 3, and 2, I have a line going downward like this. Now what I need to do is to figure out what is happening near as I get close to 3 on this piece, basically. And I can either graph that line, or I can tell that the line actually ends at, if I plug in 3, it ends at 3 times 4, so 3 times 4. See, 3 is not part of that, but I can plug it in to find an empty point in there. So that's 12 minus 3 or equal to 9. And basically it's 1, 2, 3, all the way to 9. But I don't want to get out of the page, so I'm not going all the way to the very top, but it's probably over here somewhere. But there you will have an empty point. It's over here was full point because point was included. Over there is an empty point, and then it goes down somewhere somehow this way. The entire shape is not important to me. It's just the important part of it is that I can see that all the points from negative infinity for y values, I can get every point from negative infinity all the way to that point 9 basically. So negative infinity and 9, but not including is the answer. Again, these things are going to, the both lines are going to the negative infinities basically.